Hi, I'm Igor Gerbylev, Technical Director of Just AI and ML Platform Account. So my presentation will be devoted to productization of ML models and how we understand it and what solutions in the field we have done. First of all, I will tell you as to why we needed ML platform in the first place. And then I will talk about some interesting solution that we did on the platform. And then I will talk about some other products that are important to be used to implement our concept. In Just AI, since 2016, we've been developing solutions in conversation AI, and we did several of our products, chatbot platform, and synthesis voice, and a lot of other projects for computer customers. And in the course of our activities, we have to work with a lot of ML models to test them, to probe them, to train them using the customer's data, and integrate the solution to further go to production in our own cloud or customer servers. And in the course of such activities, we have made up some requirements to the infrastructure and the platform to work with the models. First of all, it's user-friendly interfaces to interact with models for testing them, automated model training, because very often we have to fine-tune the models for specific, to customize them for specific projects. Also, an ability to manage a large number of models, because in the framework of one project, many versions of a model can be tested, different architectures, and also there are many of them, such projects. And also important is the fact that for each model, we have to have an idea of the non-functional requirements and how much hardware, how it is scaled, and so on. So thinking about how to solve all those tasks, we decided why not to look at the ML product as a product, internal product. Our ML development department is the developer, and the consumer is the applied development customer. And then we decided to build a platform that would simplify the process of creating and utilizing such products to solve the same, and not to solve the same tasks anew every time. So we said that ML platform becomes a product, and what does it mean? That's something that has value for the consumer, this product, and what he's ready to buy. For the customer to make his choice, he should have some ideas about the product, what problems it can solve, for whom it is made. So, and the product should have very easy access, and you know how to obtain it, where to find it, how to integrate it, and obviously a clear-cut cost. And the cost of it can be expressed not only in the IP call cost, but also the requirements to hardware, MLOps, DevOps, and other associate costs. They're parts of the cost. And, of course, the quality should be clear-cut. And what happens if there are many products? Well, a line of products, that's the notion that comes to the stage, and they should be combined in the single interface, and they should be interchangeable. So this term productivization is not just the process of packaging the product. It's the process of packaging into a convenient and understandable form for use. And understandable not only to ML specialists, but also to application developers, DevOps, for instance, and other project managers involved. A productivization platform also is a software framework that assist in creating such products and making it accessible to users and solves the general tasks. So now let's get over to the main part of my presentation, which is conceptual solutions we implemented. The central notion of our solution is ML service. That's the product package exactly. And ML service consists of model weights, binary artifacts, code for inference and training, Docker image with a program build, and of course its documentation and API specifications. And two more important things, configuration settings for service deployment, of course, of this service, and options of configurations of training, of the option for inference execution, and also resource specifications required for deployment. Servers, models, and GPUs, and so on. And also, let's look at the ML service from the other side, from the point of view of the code. ML service is almost unusual microservice, but that implements a specific contract consisting of init, fit, and predict. This interface here is generalized. The methods are the same, but they can operate by different structures of data, and the specification of this data structure they produce exactly the object of specification of this ML service. And here there is an example of how ML service looks in our product. It has the identifier, text for search, documentation, and lower you can see the data structures and also form for tests, which can be very different for different types of services. The next important concept is derived service. Derived service is the concept upon which we build the training process. As a result of training, we thus create, as usual, binary artifacts containing with the weights, and also derived services which copy the settings from the base model and thus obtains additional parameters which indicate the artifact with the weights it should use. In the rest, the derived service doesn't differ much from the base one or any other. And here on the screen, you can see the trained service card in form of testing form. It's the training launching testing card, so you have to load your data set or create in our system, and further to put the title of the derived service. As a result, you will have this kind of service, the one we saw on the previous slide. So from the point of view of how to create an ML service, it is very easy to do. You have to just connect to our SDK and implement and expand the base class init, predict, fit, and identify the structure of data it will work with. So the next important component is the gateway. Here you can see a very simplified architectural scheme, but Gateway is the central communication component through which customers' applications are interacting with ML service. Gate here serves as a middle layer, which on the one hand it is connected to the services. They can be deployed just anywhere by definition, or by default it can be in our clusters, or maybe some designated servers or other data centers in computers of developers. Those services are connected to G2, and then they connect to the bus and become accessible to external users through the gate. So this solution of creating such a middle layer or communication hub simplifies the deployment of services very much, and you can launch them wherever, because there are no requirements for infrastructure of Kyla. And also what we can do is implement a big number of auxiliary logic at the level of the gateway. Gateway does a lot of functions here. The main ones here, namely, are access control and load balancing and failover, auto-scaling, on demand, which is a very important element, which allows us to manage a big number of services and models, and they can be 100, 1,000, 2,000, whatever. But the platform can manage those services on its own and would launch only those which are needed now.
And Kyla 9 performs a number of functions, such optimizing the flow of queries, caching, and batching. So we do it in a dynamic batching, which is simply collecting, fragmenting customer queries within a certain time frame or before a certain size stack is ready, which we then forward to the inference at one go. Right. And of course, the system enables one to maintain service catalog as well as tariffing if these are paid for the services. Just a bit of a historical reference. The Kyla platform development is something that was started back in 2018. First, it was an in-house component, then it became part of the JCP, and later on, it transformed into a fully independent, publicly available service, and so its current shape and form is thanks to the Freed Foundation support. Now, I will say a few words about the similar or related products. First of all, Hugging Face doesn't require any introduction. The basic essence of Hugging Face is the notion of a model and a model card. In the first place, Hugging Face views the model as a binary artifact, whereas the code is somewhere separately on GitHub, but Hugging Face has additional functionality, inference endpoints, which make it possible to create production-ready API endpoints for demo application, as well as auto-training piece, which makes it possible to launch training without any encoding, simply just uploading your own data. So from Hugging Face, we're slightly different by a conceptual attitude, because our model cannot exist without the model, without the code and services that process it. So primarily, the functionalities are quite alike. The next product, which is Bento ML, a very interesting framework library, whereas Bento ML positions itself as a platform to develop AI applications. You can also describe it as MLX frameworking, because they solve a lot of MLA problems. They maintain a functioning catalog like we do. They distinguish the AP sharing logic from inference logic, so they simplify the container batching and the dependency management, as well as providing the inference optimization, very quick API batching, and a number of other functions, and even make it possible to launch services in the cloud from the command prompt. Bento ML is a product for the developers, for the ML developers, as well as the application engineers, and is aimed at producing a single product and with its subsequent independent application thereof. And so if in your company you're not yet using any big platform, it might be a good idea to take a closer look at Bento ML. The next product is ClearML. It is positioning itself as an ML option as a full cycle platform, but the biggest value can be found in developing an ML pipelines which enable one to automate and optimize the ML experimenting. The key essence of it is that the notion of experiment and problems, or the jobs that take certain input data, then do training testing, produce reports and binary artifacts, which later on are supposed to be integrated into an ML service or a solution. And ClearML is an outstanding tool for ML engineers. In our concept, it can be used at the stage of developing an ML service. The next group of solutions are the optimization frameworks and library frameworks like Triton, N-scale Ray, High Delta TGI. So these kinds of options are intended to develop production-ready inference services which are capable of taking big loads, or, for example, to optimize training or unbundling simultaneously in between several workers. So our platform, like in the case with Bento ML, duplicates certain functions of these products, and specifically, scaling, load allocation, batching, and at least for some services, the kind of Bento functionality could be sufficient for moving away from the need to integrate additional solutions, because to develop a kind of service is simpler than to integrate Triton or Ray. And in case what we have is not enough, then nothing is in the way to utilize any solution or any library at the level of developing a specific ML service. Right. So in my presentation, in the first place, I wanted to share with you an ML service concept and demonstrate that this is a convenient abstraction, convenient both for the ML service developers, for application developers who utilize this product, as well as for the platform developers who, by introducing this abstraction, are able to bring investing in a big number of support functions rather than put them on the shoulders of the ML developers. And so the concept of the derivative services has proven its worth quite well in our work. So the ML service concept, the way we understand it, may serve as a convenient framework to establish collaboration between ML development and its execution. While one can employ this kind of approach, is possible by using either our platform or other set of solutions. That is it. Thanks very much for your attention. It's my Telegram. Please get in touch. I will be happy to respond. Thank you.